Okay, so these were the things which we have discussed in our previous sessions. Okay, so today we are going to start with what? So then we had started with the nomenclature. Okay, then we had started with the okay. Okay. So we were discussing the nomenclature in our previous session. Okay, so we have seen some of the uh, molecules. Okay, let me take a blank slide. Okay, so let me take a. So we have seen how to name the how to give the common name as well as the IUPAC name. Okay, so we have started with the nomenclature in our previous session. So we are continuing. So we had seen some of the molecules. Okay, so I have given you some of the molecules, some of the structures as homework. Okay, so so let us solve that now. So the first structure which I had given was this. Okay, can you give me? So we were discussing the common name as well as the IUPAC name. Okay, so please tell me the common name as well as the IUPAC name for this particular structure. Yes, can you give me the name? Okay. Yes, what is the common name and IUPAC name for this given structure?
N-propene bromide.
N-propene bromide. Okay. See, we have seen the system, right? So we have seen the nature of the carbon. Okay, we have seen the nature of the carbon when the halogen is attached. So we have seen some types of halides. Okay, so please apply that here. We are studying what? We are studying haloalkanes and haloarenes. Okay, so in that, when we are seeing the classification, so when you have a double bond system, right? So these are classified under one. So these are classified as what? So the halogen atom, okay, is attached to a carbon, which is sp3 hybridized, which is next to a carbon-carbon double bond. So these are termed as what? What they are termed as, students?
Allylic carbon.
Yes, so they are called as allylic. So this is the common name given is allyl bromide. Okay, so allylic halide. So which is the halide here? Bromide. So it is allyl bromide. Okay, it is called as what? Allyl bromide.
My.
Okay. So what is the IUPAC name? Now you have to apply the IUPAC name. So IUPAC name first will be your halo substituted followed by the alkane name. So let me number the system. So it will be from 1, 2, and 3. Okay. So okay, now you can tell me the IUPAC name. Yes. So what it is? At 1
bromo,
yes. 1 bromo.
Propene.
prop 2 ion.
Yes, correct. 1 bromo. Okay, then probe because there are 3 carbon atoms. Okay, because there are 3 carbon atoms. So probe, and then at second position you have double bond. So it is 2-ene. Okay, so this is the name. Okay, let me go for the next one. So this is the next molecule. Okay. So this is the next structure. Okay. Now you can give me the common name and IUPAC name of this. So,
Aryl
yes.
chloride.
ಇವಾಗ ಅಲ್ಲಿ ಹೋಗಿದ್ದಾರೆ ಸಪ್ಲೈ ಮಾಡಕ್ಕೆ ಬರ್ತಾರೆ 4 ಗಂಟೆಗೆ.
Okay. Aryl
Chloride.
chloride. Okay, that is aryl chloride. So if it is a aryl substituted chloride, okay, that is also fine. So if I take this, okay, aryl, correct. If I take this as parent chain, what it is called as? When you have a benzene with a CH3 system, it is a toluene. Okay, so toluene. So at one position you have fluoro. So when you have 1,2 substitution, it is called as orthochlorotoluene. Okay. Now IUPAC name. IUPAC name. IUPAC name. IUPAC name. Yes. The IUPAC name is 1-chloro 2-methyl benzene. Okay. So this is the IUPAC name. Okay. Next. Next compound. Okay. Let me do this. Maximize this slide. Yes, what is the name? So this is what, when you have a halide, okay, so this also we have classified. So whenever you have a halogen attached to a sp3 carbon, which is next to aromatic ring, what it is called as?
Benzylic halide.
Yes, so this is what? Benzyl chloride.
Chloride.
Yes, it is a benzyl chloride. Okay, can you give me the IUPAC name? The IUPAC name is what? It is, so this is a phenyl chloromethane. It is a phenyl chloromethane. Okay. So how it is phenyl chloromethane? See, CH4. Okay. So in CH4, one of the hydrogen, okay, one of the hydrogen is replaced by Cl and one of the is replaced by a benzene ring. So it is, this is a phenyl group, this is a chloro group, and this is a methane. So it is phenyl chloromethane. Okay. So two more, CH2Cl2. Okay. The common name and the IUPAC name, and CCl4. What is the name? So this is methylene dichloride. Okay, the common name, and the IUPAC name is what? Yes. So two, this is replaced by, two hydrogens are replaced by chloro. So it is a dichloromethane. Okay. Next one, CCl4. So this is carbon tetra, 4 chlorides, right? So it is carbon tetrachloride. Then what is the IUPAC name? First will be your prefix tetra, chloro, and then methane. Okay, so these are the IUPAC and common name. So one more thing. So whenever, okay, so this is the nomenclature. So whenever you have dihaloalkanes, okay, whenever you have dihaloalkanes and the halogen atoms, okay, same halogen atoms, if they are present on the same carbon, suppose, okay, so this is the, what? This is the structure. Okay, if I write like this, CH, Cl2, CH2, okay, like this. So if I illustrate this, CH, Cl, Cl, C, H, H and H. Okay, so if the halogen atom, are present on the same carbon, right? Then they are called as what? They are called as geminal dihalides. Okay, please remember these words. They are called as geminal dihalides. Okay, then one more system. When you have the halogen atoms present on the adjacent carbon, okay, when they are present on the adjacent means what? Sidewise, okay, on the present on the side carbon. You can see on the other two carbons, right? Side carbon. Then these are called as what? They are called as vicinal. Okay, they are called as vicinal dihalides. They are called as vicinal dihalides. Is it clear? Yes. So these are the important nomenclature, okay, which are to be studied. Okay, so we have discussed the important things. So now we will see next is the nature of CX bond. Okay, nature of CX bond. Now what is the nature of CX bond? Fine. So in alkyl halides, now you know what are alkyl halides, right? Alkyl halides means what? Alkyl halide means one of one or more hydrogen atoms are replaced by halogen atoms, okay, in an aliphatic system, then they are called as alkyl halides, okay. Now in the alkyl halides, okay, how the alkyl halides will be? So one of the hydrogen is replaced by halogen. So this CX bond, it is partially polarized. Why it is partially polarized? What do you mean by polar bond? So we have discussed this in the previous section, okay, in the solution chapter. We know now what is a polar bond, what is a non-polar bond. Can anyone tell me what do you mean by polar bond, students? Yes. What do you mean by polar bond? So polar bond means what? Whenever a atom, okay, whenever a atom is more electronegative, okay, when so this polar bond, it arises due to the presence of a atom, okay, which is more electronegative, or it the polar bond arises due to the difference in the electronegativity, okay. Now when what is X? X is a halogen. What are the halogen halide? So fluorine, chlorine, bromine, iodine. Okay, so these are the halogens. So whenever any halogen is present, if there is a presence of halogen atom, okay, as you know, halogens are highly electronegative. Polar bond, what polar bond? It arises, polar bond arises due to difference in electronegativity, okay, electronegativity. So why the polar bond arises? It arises due to the difference in electronegativity. So here, when carbon and halogen atom is present, so this halogen atom, as it is attached to a carbon bond, what will happen? There will be a difference in the electronegativity, and thus partial negative charge will be developed on halogen and partial positive charge will be developed on carbon atom. Okay. Why? Due to the presence of halogen atom. So this is due to minus I effect. Okay, that is minus I, that is inductive effect. So whenever you have atom, okay, electronegative atom, okay, so as it has a tendency to pull the electron towards itself, as a result, there will be development of partial negative and partial positive charge. Now, what will happen to the electronegativity? Okay, now as you see, so in the period, so like this in a group, okay, in a group, the halogens are they are arranged like this. Okay, how they are arranged? By increase by, okay, so as you go down the group, what will happen to the size? The size of the halogen atom will increase, right? So size of the halogen atom increases as you go down the group, right? Now what will happen to the CX bond? Okay, what will happen to the CX bond? The CX bond, as you go down, the length also increases. Okay, the CX bond length also increases from CF to Ci. So as you go from fluorine to iodine, what will happen to the bond length? The bond length also increases. Why it increases? Because as you go down the group, what will happen to the size? Size will increase. Okay. So this is the nature of your CX bond. Okay. So this is the nature of your CX bond. Is it clear? Yes. Is it clear? Okay. Others have understood. Okay. So next. Okay, so next we are going to start with the methods of preparations. Okay, what do you mean by methods of preparation? We are going to see how you can prepare the haloalkanes. Okay, what are the different methods? What are the different methods from which the haloalkanes can be prepared? So these are some of the general methods. So these are the general methods from which you can prepare your haloalkanes. Okay, so let us start. So with the general preparation. So first is we are going to see from alcohols. Okay, so these are some of the general preparations. So from alcohols, then we are seeing from by free radical halogenation of alkanes. Then we are going to see from addition of hydrogen halides on alkenes. Okay, so these are the main three. Okay, so for your exam, you have for your syllabus, you have these three general methods of preparation. So first we are going to see from alcohols. Okay, how the methods, how you can prepare the this the haloalkanes from alcohol. So that let us see. Okay, so alcohols. So how you are going to prepare now? Okay, so alcohol is our starting product. So alkyl halides. Alkyl halides, it is represented by Rx. Okay, R can be your any alkyl halide. R can be your any alkyl group. Sorry, R can be your any alkyl group. X is your halogen atom. So this is the representation of a alkyl halide, that is Rx. Okay. Now, how you will prepare? So first is by using the halogen acids. First is by using the halogen acids. So how we are going to use it? So first, alkyl halides, they can be prepared by treating. They can be prepared by treating the alcohols with halogen acid. So what are the halogen acids? Like HCl. So by treating it with HCl, what you will get? You will get what? You will obtain the alkyl halide. So this is the first method. Okay. First reaction by using the halogen acid. So by treating alcohol with the halogen acid in the presence of anhydrous ZnCl2. Okay. So this is called as Lucas reagent. What is Lucas reagent? So please make a note. Lucas reagent is the reagent which consists of HCl plus anhydrous ZnCl2. Okay. So this is what? Lucas reagent. So whenever you have a HCl and anhydrous ZnCl2, this is Lucas reagent. So alkyl halides. Okay, alkyl halides can be prepared with the help of alcohols and Lucas reagent. You will obtain the alkyl halides. Okay. Now, what by this method, what we are obtained here? We are obtained here alkyl chlorides. Okay, alkyl chloride. So, chloroalkanes or alkyl chlorides are obtained when this HCl gas is passed in alcohol, okay, in the presence of this anhydrous ZnCl2. And this process is called as Grove's process. Okay, this is a name. So remember that whenever you are studying organic chemistry, name reactions are very important. Okay, mark this as important. Mark this as important. So Grove's process. What is Grove's process? Chloroalkanes can be obtained by passing HCl in the presence of HCl in the presence of alcohol. Okay. HCl is passed in alcohol in the presence of anhydrous ZnCl2. Okay, and this is called as Grove's process. Okay, so what can be the example given? What can be the example? Shall I take alkyl halide as ethyl group, C2H5? So if I take C2H5OH, okay, alcohol, plus I react it with HCl in the presence of anhydrous ZnCl2. What will be the product obtained, students? What will be the product obtained?
Ethyl
Ethyl chloride. Okay, you'll obtain ethyl chloride plus water. Okay, plus water. Ethyl chloride plus water. So this is the first reaction. So this is what? This is our first reaction. Okay, next alcohols. Okay, now this is by this you can prepare what? Chloroalkanes. Generally, you can prepare chloroalkanes. Now I want to prepare bromoalkanes. If I want to prepare what? Bromoalkanes. So if I want to prepare bromoalkanes, what I have to take? So again, I have to take alcohol, treat it with sodium bromide. Okay, I'm treating it with what? Sodium bromide in the presence of what? H2SO4, that is concentrated sulfuric acid. What is H2SO4? Sulfuric acid. Okay, so this is also a halogen acid. So this is a sulfuric acid. Okay, so this is a sulfuric acid. So we are going to obtain what? We are going to obtain bromoalkanes and water. We are going to obtain bromoalkanes and water. So I'll give you example. What I'll take R. Let me take R as methyl group. Okay, it's methyl group. So this is a methyl and this is a ethyl group. Okay. So let me take methyl. So what will be my alcohol? My alcohol will be methanol. Okay, or it is a methyl alcohol. Okay, methyl alcohol or methanol. So I treat it with NaBr plus H2SO4. Yes, students. Can you tell me the what will be the product obtained?
Methyl bromide plus water.
Yes, you will obtain methyl or bromo. Yes. Okay, methyl bromide plus water. Yes.
Water.
So this is methyl bromide plus water. So this is the second method of preparation. Yes. Next one. So next, alcohol, when you treat it with by using phosphorus acids. Okay, by using phosphorus acids. Phosphorus halides. So by using phosphorus halides, we can obtain the next reaction. Okay. Now here what we are doing, so this PX3. PX3 is what? Phosphorus. Phosphorus halides. Okay, X can be your any halogen. So when you treat alkyl halides, okay, when you want to obtain alkyl halides, so what you'll get? You'll obtain alkyl halides. So alkyl halides can be prepared by reaction of alcohol, okay, with phosphorus halides. So these are the different reactions. So let me clear all this. So then we will start with the so alcohols, when you treat it with the phosphorus trihalide, okay, this is phosphorus trihalide because there are three halogens, PX3. So PX3 is what? Phosphorus trihalide, okay, trihalide. So your halogen can be what? Your halogen can be your X3. Okay, your X3, it can be, you can use bromine, okay, or you can use chlorine like this. Yes. So now what I'll take bromine. Okay, I'll take bromine. Okay, let me take bromine, or you can take iodine also. Okay, you can take iodine also, but I'll take bromine. So I'll take which alcohol? So shall I take ethyl? So I'll take ethyl. So ethyl alcohol, I treat it with phosphorus. Uh, I'll take chloro only. Okay, then it will be easy for us. So let me take phosphorus trichloride. So generally we make use of phosphorus trichloride. Okay, then what we'll obtain? What will be the product obtained, students? It will be, so I'll take 3 moles of this. What I'll take 3 moles of ethyl alcohol. Okay, so this is a ethyl alcohol. I treat it with what? Phosphorus trichloride. I'll obtain ethyl chloride. Okay, I'll obtain ethyl chloride. So this is the what? This is the product which is obtained. And what will be the side product? It will be H3PO3. H3PO3. Okay. So alkyl halides can be prepared like this. So you are going to get this alkyl halide. Next is the second method. Alcohols, when you treat it with phosphorus pentachloride. Okay, if you treat it with phosphorus pentachloride, penta means 5. Okay, when you treat it with phosphorus pentachloride, what will obtain? Chloroalkane plus POCl3 plus HCl. So if I take again now R as CH3, okay, example CH3OH plus PCl5, what I'll obtain? I'll obtain CH3Cl plus POCl3 plus HCl. Okay, so this is the product which is obtained. So these are the 4 reactions we have seen till now. Okay, next is also you can prepare. Okay, you can also get, so ethyl alcohol. Okay, if you treat it with red phosphorus in the presence of bromine. Okay, with red phosphorus also you can prepare you can do the reaction. Okay, you can obtain ethyl bromide. So this is another example. So if you treat uh, so bromides, all you can use iodide. Okay, you can use either of this. You can get the respective alkyl halide. So this is another method. So wherein you can use red phosphorus. You can, if you want to prepare a bromo, use Br2. If I want to prepare iodo, that is ethyl iodide, then I'll use I2. Okay, so like this. So this is a very important reaction. So we have seen 4 reactions. So let us go for the last one. So alcohol. So this is very important. Okay, this is also very important. So first Groves method and this. Okay, Darzan's method. So Darzan's method and Groves method is very important. Okay, Darzan's process and Groves process. Mark this as important reaction. Okay, let me clear this. So we'll see the next method. So from this method, you can obtain chloroalkanes. So chloroalkanes are prepared, okay, by refluxing the alcohols, with thionyl chloride. What is SOCl2? SOCl2 is thionyl chloride. So alcohols, when you treat it with thionyl chloride in the presence of pyridine. What is pyridine? Pyridine is a base. Okay, it is acting as a base. It acts as a base. So chloroalkanes can be prepared by refluxing your alcohols with thionyl chloride in the presence of a base like pyridine, and this process is called as Darzan's process. Okay, important for 2 marks. Important for 2 marks. What is Darzan's process? Give an example. Okay, what you will write? Chloroalkanes can be obtained by refluxing or by treating the alcohols with thionyl chloride in the presence of pyridine, and this process is called as Darzon's process. Important for 2 marks. Okay, if they ask you write the general reaction, so what will be the general reaction? Alcohol. So you have to, so whenever you are writing the reactions, make a habit of writing the names also. Okay, make a habit of writing the names also. So alcohols, you treat it with what? You treat it with thionyl chloride. Okay, in the presence of pyridine. So this is a thionyl chloride. So make a habit of writing the names. Okay. So thionyl chloride in the presence of a base, what you will obtain? You will obtain the alkyl or chloroalkane plus SO2 gas is released. So whenever you are writing gas, the gas will be escaped out. Okay. So why this method is used? Okay, this method is mostly preferred. So this is a most preferred reaction. Why? Because the byproduct obtained are gases, and these gases can be removed easily. Okay. So this method is mostly preferred. Why this method is mostly preferred students? Because you can see the byproducts obtained are what? These are gases. SO2. Okay, sulfur dioxide is also a gas and hydrochloric acid is also a gas. So these gases will escape out easily, or it can be removed off easily. So because of this, this is a preferred reaction. So let me take an example. So if they ask you general reaction, so you have to write this way. If they ask you explain Darzon's process with an example. So take any of a alkyl halide. So let me take a ethyl. Okay, so ethyl alcohol plus thionyl chloride in the presence of pyridine. What you will obtain? Ethyl chloride plus SO2 gas plus HCl gas. Okay, so this is a, you have to write the name. So this is ethyl chloride. Okay, this is ethyl alcohol. Understood? Yes. Are these name reactions clear? So we have seen the first set of reaction, that is from alcohols. Is it clear? Okay. Others? Okay. So let us go for the okay, so in Grove's method, zinc chloride, okay, that is ZnCl2 is used to weaken the COH bond. In case of tertiary alcohol, zinc chloride is not required. Okay, so these are some of the important notes. Please read it. So the reactivity of halogen acid. So whenever we are considering the halogen acid, okay, the order of reactivity is HI is more reactive than HBr and then the HCl. And the reactivity towards the alcohol is that tertiary is more stable. Okay, tertiary is more stable than secondary alcohol and then the primary alcohol. So this is the reactivity order. So please remember so this is the reactivity order of alcohols. Okay, so tertiary is more stable, then secondary, and then your primary. And the reactivity of this halogen acid is HI is greater than HBr and HCl, and the reactivity of alcohols towards this reaction. Okay, the reaction of Grove's process. So tertiary will be more stable, then secondary, and then your primary. And for Darzon's procedure, so as we have discussed, Darzon's process is the best method for preparing the alkyl halides. Why? Because the byproducts obtained are SO2 gas and HCl, and these gases will escape out easily. Okay, so these were the important points. Okay, so this you have to remember. So next we are going to see is from hydrocarbons, that is from free radical halogenation of alkanes. Next we are going to see free radical halogenation of alkanes. Okay, so by free radical halogenation, so free radical you can do chlorination. So this is a chlorination. Okay, you can see here we are using chlorine. So this is a halogenation, we are using chlorine. So it is a chlorination. This is a chlorination process. Okay, So free radical chlorination or the bromination. How it is bromination? Bromination because if we are making use of Br2, then we can do bromination also. So here we are doing free radical chlorination of alkane. So we are taking a alkane. Which is a alkane? Which is this alkane? How many carbon atoms? 4. So what it is? Which alkane it is? Yes.
Butane.
Yes, it is a butane. So we are doing free radical chlorination on a alkane, that is a butane. So what we will get? We will get a mixture of mono, di and polyhaloalkanes. Okay. So how we will get the mixture? So, and these are very difficult to separate. So let me illustrate it here. So I am going to take a alkane, that is CH3, CH2, CH2 and CH3. So this is a butane. So I am doing what? Chlorination. So how we will do free radical mechanism? We are taking a halogen in the presence of H nu, that is your light. You are making use of UV light, or you can take heat. Okay, it should be in the presence of a light, or it should be in the presence of a use of halogen in the presence of the free radicals will be generated. So butane, we are providing UV light or heat. What you will obtain? Okay, so what will happen first? So either it will see here the carbon is symmetrical. What do you mean by symmetrical? The alkane is symmetrical. So if I break this bond, okay, if I see the number of carbon atoms, they are equal. So symmetrically, it can be broken. So on either side, there are 2. So this is also same. So this same carbon, this is also same. This is also same. So either the chlorine will attack on this carbon or this carbon, this carbon or this carbon. Any 2 carbon. So I'll take one side. So let me take on this side, okay, on the right side. So how the attack will take place? So first it can 2 possibilities. So first it will attack on so first possibility is that one of the hydrogen can be replaced by the Cl. So this is the first possibility. Okay. When one of the hydrogen is replaced by Cl. Second is it can attack on this. So another is CH3, CH2. Okay. One of the hydrogen is replaced by Cl and this is CH3. So what are the names now? Can you name it? So 1, 2, 3, 4. And here 1, 2, 3, 4. Okay, please name it. This is 1-chlorobutane. And this is 2-chlorobutane. Is it clear? Free radical mechanism. Because it is a symmetrical carbon. Because it is a symmetrical carbon, you can both the carbon atoms are same. So either of the side, okay, any of the so at one product you will obtain at this carbon, another product you will obtain at another carbon. So these are the 5 products obtained. Is it clear? Yes. Is it clear? Let me give you an example on this. I want the answers from you all. Okay. So I'll give you a reaction. So CH3, CH, CH3, CH2, CH3 plus Cl2 in the presence of UV light. Okay. Give me the products now. Give me the product. Yes, students, give me the products. So is the, first of all, is the structure symmetrical? Symmetrical means if you break the, in the center, okay, is it identical on both the side?
No, ma'am.
No. Okay. So there are how many possibilities of the attack? How many?
1.
Is it 1? Okay. Let us start. So the first possibility is that it can attack on this carbon. So what will be the product? CH3, CH, CH3, okay, CH2, CH2 and Cl. So this is the first product. So if I name this, okay, if I name this, what will be the name? 1, 2, 3, 4. Okay, so what is the name? 1 chloro, 3 methyl and butane. Okay, so this first is a possibility. Okay, let me see the second structure. Okay, so second possibility. So this was the first possibility of the attack of this. Second is it can attack on the least carbon here on the second position. So this can be the second CH3. This will be what? Cl, H, okay, and CH3. Okay, give the numbering. If I number this 1, 2, 3, 4. Okay, give the name. What will be the name? 2 chloro,
2 chloro, 3 methyl butane.
3 yes, good. Okay, so this is the second possibility. Well, the attack can be possible on this carbon. Third possibility. Okay, so CH3, C, Cl, CH3, CH2, and CH3. So give the numbering now. Give the numbering. What will be numbering? 1, 2, 3, 4. Okay, give the name.
2 chloro, 2 methyl butane.
Yes, correct. Good. So 2 chloro, 2 methyl butane. Okay. Any other possibility of the attack? Yes. Okay. It can attack on this carbon. Okay. It can attack on this carbon. So this is a fourth possibility. So let me write that also. So it will be CH2, Cl, then CH, CH3, CH2 and CH3. So if I give the numbering will be 1, 2, 3 and 4. Give the name. 1 chloro,
2 methyl
2 methyl
butane.
butane. Yes, good. Okay, so these are the possibility of the attack. Okay, so these are the different possibilities. So so these are the possible structures of free radical chlorination. Where I have attached 2Cl. Cl can't be attached on same carbon chain. Can be okay. No, okay, free radical. We are doing free radical. Okay, now suppose it depends on how much you are supplying. Okay, now if I have methane, okay, if I have methane and I'm doing continuously chlorination. Okay, if first suppose, should I clear this? First of all, is it clear? Should I clear? Then I'll tell
Yes,
you.
ma'am.
Okay, so take methane. I do chlorination on this. Okay, so first chlorination, what will happen by Cl? Suppose again I am doing chlorination. Okay, again I have supplied the light and again I have given the halogenation. Then what will happen? Again CH2, Cl2. Again, okay, I have not stopped. It depends on how much you are supplying. Now again I am what? Supplying UV light and I have given the halogenation method. Okay, so what will happen? It will be CH3, Cl, not CH3, CHCl3. Okay, CHCl3. Again, I have provided the conditions. Okay, Cl to what will happen? CCl4. So it depends on how much you are applying. Okay, so it is possible. So at on the same carbon, you can what will happen? 2 halogen atoms are also possible. 4 halogen atoms are also possible. It depends on how much this is your supply. Okay, okay, good, fine. So this was the first method. Next is addition from alkene. Next is from alkene. So addition of hydrogen halide. Okay, next is addition of hydrogen halide. So this is a addition of hydrogen halide. You can see hydrogen halide. What do you mean by hydrogen halide? HBr. Okay, alkene means you have a double bond system. Suppose, okay, suppose I have a symmetrical alkene. Now, what do you mean by symmetrical alkene? If I, okay, if I break or if I keep a center, okay, if I put a line in the center, you can see on the either side, same number of atoms are present, right? Same identical atoms are present. So this is said to be symmetrical alkene. Now, whenever you are adding a hydrogen halide across the symmetrical alkene, so either of the carbon, if it, okay, either of the carbon, the hydrogen will attack on one carbon and bromide will attack on another carbon. On either, on any of the carbon it can attack, because it is a symmetrical alkene. Symmetrical means what? Okay, on either side the number of carbon atoms are same. Suppose one more example. Okay, so this is what? This is also a symmetrical alkene. Okay, so if I put HBr, what will happen? If I put HBr, I'll write the product here itself. So here itself, one hydrogen will add and one Br will add. Okay, or anywhere, Br and here hydrogen, like this. Okay, so this is about symmetrical alkene. Now, okay, now suppose I have a unsymmetrical alkene. Now suppose I have a unsymmetrical alkene, unsymmetrical CH3, CH and CH2, okay, plus HBr. Now how will unsymmetrical means now what? Unsymmetrical means when you put a line, okay, at the this what? Middle of the your this double bond. Okay, what will happen? Can right? They are not similar, right? So this is said to be unsymmetrical alkene. Now add that unsymmetrical alkene. So which is the alkene? Can you give the name of this alkene? What is the name of this alkene? It is a
Propene.
yes. It is a propene. Good. Yes. Okay. Now this is a propene. Now, how the addition will be possible? How will you add this hydrogen halide across this unsymmetrical alkene, students? How will you add the addition of this hydrogen halide across this unsymmetrical alkene?
I'm removing of double bond.
Okay, fine. I'll remove the double bond. Fine. I'll remove the double bond. Okay. Now at one carbon, I have one hydrogen. Another carbon, I have two hydrogen. So where I'll add hydrogen and where I'll add bromine? Yes. So whenever I had symmetrical alkene, okay. Now whenever I had a symmetrical alkene, HBr, okay, I could break one bond and I could add anywhere, okay, anywhere, like this. H, H, H. Means what? It is CH3, CH2, Br. Okay, it will result into what? It will result into ethyl bromide only. Now, if I have a unsymmetrical alkene, okay, unsymmetrical alkene, then it is very difficult to add this hydrogen bromide across this double bond. So that time we are going to use one rule. Okay, we are going to, yes, we are going to use a rule, and that rule is called as Markovnikov's rule. Okay, it is Markovnikov's rule. So what is this Markovnikov's rule? Okay, so whenever you have a symmetrical alkene, no problem. Okay, we don't have any problem that time. But whenever you have a unsymmetrical alkene, so that time the problem will arise. Okay, that time the problem will arise. So that time we are going to use what rule? We are going to use Markovnikov's rule. So what is this Markovnikov's rule? So alkene will add a molecule of hydrogen halide, okay, to form the alkyl halides. So this addition to unsymmetrical alkene, it will take place according to Markovnikov rule. Okay. So Markovnikov's rule states that whenever you are adding HBr, so HBr will be added, that is a hydrogen halide will be added across the double bond to an unsymmetrical alkene. So the negative part, okay, the negative part will be added to the carbon which is having, so negative part. Now whenever you are having hydrogen bromide, okay, which is having negative part, your bromide. Okay, if I break this bond, so carbon will, hydrogen will be H plus and bromide ion, okay, bromide ion will form. So bromide is the negative part. So negative part will be added to the carbon having least number of hydrogens. Okay, and least number of hydrogens, yes, hydrogen atom, least number of hydrogen atom, and hydrogen atom will be, or and hydrogen will, right, not atom, hydrogen will be added, hydrogen will be added to carbon having more hydrogen atoms. Okay, so now apply this and give me the product. Give me the product. So there are two possibilities. Okay, now I'll write the two possibilities. So if I attack the negative at here, so there is a possibility that it can form CH2. This will be CH2, and here I am adding Br. Another possibility is CH3, CH, Br, and CH3. Okay, so which is following the Markovnikov rule and which is following the and forms alkene. Okay. Yes, which is following the Markovnikov rule here, which is a major product and which is a minor product according to Markovnikov rule. Second one. Second step. Yes, second one. Okay. So negative part. So this is a 2-bromopropane. So this is the major product. Okay. So this is our Markovnikov rule. Okay. So like this, and this is a minor product. Major means what? Major means more yield. Okay. More yield you will get of this product, and this will be a minor, less yield. Okay. So this is the Markovnikov rule. Is it clear? This is a Markovnikov rule. Okay, so this is Markovnikov rule, which is given generally here. Okay, so that only I have explained. So what is Markovnikov rule? Markovnikov rule states that whenever you have an unsymmetrical alkene, the negative part of the hydrogen halide will be added to the carbon having least number of hydrogen atom, and the hydrogen will be added to the carbon having more number of hydrogen atom. Okay, which will be more stable. Yes, major product will be more stable. Major product will be more stable. Okay, major product will be more stable. Fine. Okay. So next possibility is that, okay, whenever you are adding, I have a what CH3, CH double bond CH3. Again, I have unsymmetrical alkene. I am adding a hydrogen halide, but the possibility is that I have a peroxide. Now, what do you mean by peroxide? Peroxide means you have an extra OO linkage. For example, H2O2. What is this? It is a hydrogen peroxide. What it is? Hydrogen peroxide. In peroxide linkage, you have a OO linkage. Okay, you have a OO linkage. So this is a hydrogen peroxide. You have a OO linkage. Okay, oxygen linkage. So hydrogen peroxide. Suppose I have a sodium peroxide or I have a benzoyl peroxide. So whenever there are some organic peroxide, okay, if on the arrow peroxide is written, then what will happen? They will follow anti-Markovnikov rule. Anti means what? Anti means reverse of Markovnikov rule. Okay, it will be reverse of Markovnikov rule. So when is written on the arrow mark, okay, if peroxide is written on the arrow mark, what will happen? It will follow anti-Markovnikov rule. So which will be the major product here then? What will be the product obtained? Yes, students, what will be the product obtained? What will be the product? It will be reverse. Okay, anti means reverse. Okay, ulta. Markovnikov rule the ulta. So what was Markovnikov rule? The negative part will be added to the carbon having least number of hydrogen atoms, and hydrogen atom will be added to the carbon having more number of hydrogen atoms. Now it will be reverse. So what will happen? What will be the answer? Here the negative part will be added to the carbon having more number of hydrogen atoms, and the hydrogen will be added to the carbon having least number of hydrogen atoms. So that time in anti-Markovnikov rule, the major product will be this 1-bromopropane. What it will be? 1-bromopropane. Is it clear? So this is Markovnikov rule and anti-Markovnikov rule. Is it clear, students? Okay. Others have understood. So today we have seen, yes, so today we have seen the remaining nomenclature. Okay, so please study. So today just revise again what are allylic halides, what are benzylic halides, what are vinylic halides, okay, what are aryl halides, then what are vicinal dihalides, what are geminal dihalides. Okay, so these are the important things which you have to revise. Then we have seen what is the nature of CX bond. Okay. Then we had started with the methods of preparation. So first method we have seen with the alcohols. Okay, how we can prepare from alcohols the different alkyl halides. So these are the reactions which we have seen. Then we had started with hydrocarbons, that is by free radical mechanism we have seen. Okay, free radical halogenation of alkanes. Then we have seen the what addition of hydrogen halide. So we have seen what is Markovnikov rule and what is anti-Markovnikov rule. Okay. So the remaining methods of preparation we'll be discussing in the next class. Is it clear? Yes. Fine. So if you have any doubt, ma'am, how to find major and minor product? Okay. See here, Markovnikov rule. Whenever Markovnikov rule means what? In the symmetrical alkene. Okay, in the unsymmetrical alkene, suppose one example, in exam, they will not give you anything. So they will give you unsymmetrical alkene. Okay, and they'll give you what? They will give you HBr and they'll ask what is the product. So that time, what you will apply? You will apply your on the arrow mark, there is nothing. Okay, on the arrow mark, there is nothing. So what it is? It is a Markovnikov rule. So that time, what will be the product? It will be CH. You know Markovnikov rule. Apply the Markovnikov rule, and that time this is a major product. Suppose if they give in the exam like this, CH double bond CH2 plus HBr. Okay, in the presence of peroxide. Okay, on the arrow peroxide is written. So that time, what we will apply? What will be the rule? It will be anti-Markovnikov rule. What will be the product? It will be ulta, right? Anti-Markovnikov rule. The rule is ulta. So this will be the major product. Okay, so depending upon what is asked, you have to write the products. Is it clear? Study Markovnikov rule clearly. Okay, then you can write anti-Markovnikov rule because it is reverse of that. Is it clear? Okay, fine. Okay, fine. So I hope everything is clear. So the next part, okay, remaining methods of preparation we'll be discussing in the next class. So I'll end the session here. We'll meet in the next class. Thank you.
Thank you, ma'am.